Alright, so hey everyone, good afternoon. Hope your day is going well so far. Today is day 3 of our polynomials unit. Today we're going to talk about graphing polynomials with zeros that have multiplicities. Multiplicity is just the fancy word for like a root that repeats itself. So like you might have seen this in the context of algebra 2 as like a double root, right? But if anything beyond 2, right, anything beyond a double root, we say it has a multiplicity of 3 or 4, etc. Alright, for your do now, it's p of x equals x minus 1 times x plus 2, x minus 3 squared. So this has been factored already. So if you remember from yesterday, right, the 4 steps were like find the x and y intercepts, and behavior, and then we did the number line with the intervals. For now, I want you to find the x and y intercepts and the end behavior. But yeah, I do want to get to the rest of the lesson, so we'll reconvene in like 30 seconds. Okay, so let me pause you here. I'm going to scroll up for the solution. So again, our aim for today is how do we graph zeros with multiplicities. Right, so the x-intercepts here are going to be 1, -2, and 3. So this is easy to see because the polynomial has already been factored for us. So 1, -2, 3 are the x-intercepts. For the y-intercept, we set x equal to 0. If we plug in x equals 0, we're going to get -18. Right, so that's 0 minus 1, which is -1. 0 plus 2, which is 2, and then 0 minus 3 squared, which is +9. That'll be -18. For the end behavior, one thing we have to notice is that the degree is going to be 4, right? So there's going to be x to the 4th, since we have an x here, and then x squared. So that's x to the 4th. And it's going to be positive because there's no like negative x, right? So if there's a negative x here, then that will make it a negative leading coefficient, but here it's all positive x, so it'll be a positive leading coefficient. So positive leading coefficient, even degree, that'll bring us to the end behavior of as x goes to infinity, y goes to infinity, and as x goes to negative infinity, y goes to infinity. So it goes to positive infinity in both directions. Okay, and then, well, let me pause here. So make sure you have that in your notes, and then from there I'll draw the number line. Okay. All right. So last step from yesterday was to, test the intervals to examine the behavior between the x-intercepts. So the first interval I'm going to test is the left of -2. So for that, I plug in -3 into this factored form. You're going to get -3 minus 1, which is -4, -3 plus 2, which is -1, and then -3 squared. So -3 times -3 minus 3 is -6. But you square it, so it's going to be negative times a negative, which is going to be positive. Either way, though, it's going to be a positive number here. For the sake of time, I'll just read the rest. So for the next interval between -2 and 1, I'm going to test 0. For that, you get a negative number. For 2, or this interval between 1 and 3, I test the number 2, you get a positive number. And then for the last interval, 3 to infinity, I test the number 4, and for that you get a positive number. Okay, so for the sake of your graph, you would, with all this information that we have examined, we will plot the x-intercepts, negative 2, 1, and 3, which are here. And then the y-intercept is negative 18, which is here. And then the end behavior, we know that it goes to positive infinity in both directions. And then it's positive, negative, positive, and positive. Okay. All right, but yeah, for the sake of your notes, please do have, the entire solution as well as the graph. All right, I'll give you a sec to copy that, and then we will move on to our lesson for today. Okay, is anyone still copying the solution or the graph? Please type in the chat or speak up. Okay, all right, thank you for letting me know, Salu. All right, we'll move on then. So follow-up question to the do now is, how's the behavior of the graph different at each 0? You don't have to copy this down, but just bring it to your attention. The graph crosses the x-axis at negative 2. So here at negative 2, it crosses the x-axis, and at 1, it crosses through. But at 3, right, as you can see, it like bounces off the x-axis. And this is going to be our main focus today. We're going to focus on zeros with multiplicities, right? So as you can see here, 3, the 0, 3, the x-intercept 3, has a multiplicity of 2, right? Because there's a power of 2 here. So in other words, it will be a double root, as you would talk about it in algebra 2, right? So this is because 3 is a double root indicated by x minus 3 squared as a factor of the polynomial. We say that this 0 has a multiplicity of 2. All right, what I do want you to copy down, though, is the following. So just copy down this really quickly. This is not a formal definition of multiplicity, but this is how we're going to say the word multiplicity, in this context. Okay, so this is how we're going to use this word. A multiplicity is the number of times a 0 occurs. Okay, so the number of times a 0 occurs. For the do now, right, 3 has a multiplicity of 2, right, because it's x minus 3 squared. So you can write that as x minus 3 times x minus 3, so it occurs twice. Okay, so again, multiplicity is the number of times a 0 occurs. Does anyone still need that? Okay, I'm going to move on to the rest of the lesson then. So let me give you a preview of the rest of the lesson. First thing we're going to do is graph this quintic function, so x to the 5th minus x to the 3rd. And we're going to compare that with the graph from the do now and notice a pattern. Okay. Next is the worksheet after that, but we probably won't have the time for that, but it's okay. I'll post it on Google Classroom so you can refer to the solutions. It's good practice. But yeah, well, let me start off with this graph here. Okay, so we have x to the 5th minus x to the 3rd. So first thing I'm going to do is factor out x cubed. You get x cubed times x squared minus 1. And then x squared minus 1 can be factored to be x plus 1 times x minus 1, as I wrote here. X to the 3rd can be written as x minus 0 to the 3rd times x plus 1 times x minus 1. So as you can see, the zeros are going to be negative 1 from this middle term. So I just wrote it in ascending order, right? -1, and then 0 here, and then +1 for the last factor. All right, for the y-intercept, you plug in x equals 0, and you're going to get 0, right? So it's going to be 0 cubed, so 0 times anything is going to be 0. But in this case, it was like 0 times -1, which is 0. Okay, that's the y-intercept. The end behavior, so this is an odd degree, right? So 5 is an odd number, and it's positively in coefficient, right? Positive x to the fifth. So the end behavior will be as x goes to -infinity, y goes to -infinity, and as x goes to infinity, y goes to infinity. Okay, so have this in your notes, and then in the meantime, I'll draw out the number line, which is the next step. All right, from there I'll move on to the intervals. Okay, so again, we're going to test these numbers. So to the left of -1, I'm going to test -2. For that, you're going to get a negative number. Right, so just as a recap, right, you were plugging -2 into this polynomial here. So you get, at first, -2 cubed, which is negative, right, that's -8. Then -2 plus 1, which is -1. And then -2 minus 1 is -3. Okay, so negative times a negative times a negative, that's going to be negative. You do the same for the other three intervals, you're going to have positive, negative, positive. Okay, so that's the number line over here. I'll give you a sec to copy that, and then we will talk about the graph. All right, anyone still need this? All right, I'm going to move on to the graph then. Okay, so with this information, we have the zeros, the y-intercept, and behavior, and the number line. Okay, so the first thing I'm going to do is plot the x-intercepts. So again, it was -1, 0, 1. Y-intercept was 0, 0. The end behavior, -infinity on the left, +infinity on the right. And then for the intervals, right, it was negative, positive, negative, positive. Okay. Now I don't expect you to like know this behavior, so like you don't have to like draw this graph exactly, obviously. But as long as it's consistent with the information that we have here, right, the x and y intercepts and behavior and the intervals, that's what we expect of you in this class. Okay, so that's what this graph looks like. from there I'll move on to follow-up question. So again, today's topic, as a reminder, right, it's multiplicities, so zeros with multiplicities. And I want you to notice this. So what happens at x equals 0 with a multiplicity of 3? So the graph crosses the x-axis, right? So as a follow-up to that question, what difference do you see between the graph in the do now and this graph from the example? With the do now, the graph does not cross the x-axis at x equals 3. So let me scroll up to the do now. So at x equals 3, it does not cross, right? So if you remember, right, it bounces off the x-axis, does not cross through into the negative y values, right? Whereas in this example, right, the graph does cross the x-axis at x equals 0. So we can generalize that zeros with even multiplicities prevent p of x from crossing the x-axis, and zeros with odd multiplicities cause p of x to cross the x-axis. All right, there's a lot there. Let me repeat that. We can generalize that zeros with even multiplicities, so even multiplicities as in like from the do now, it was x minus 3 squared, right? So this squared, 2 is an even number. So it prevents the graph from crossing the x-axis. But for this example, here 0 had a multiplicity of 3. 3 is an odd number. And if it has an odd multiplicity, then it does cross through. Okay, so zeros with odd multiplicities cause p of x to cross the x-axis. You don't have to copy that. To summarize that, though, I want to give you this diagram from the textbook. Okay, so this is the shape of the graph of a polynomial near a 0 with multiplicities. Okay. All right, can I get a volunteer to read just this first sentence right here? Right here.
Suppose that C is 0 of P of multiplicity M. Then the shape of the graph of P near C is as follows.
All right, thank you for that. So if it's odd multiplicity, right, as we had in the example, right, we had 0 with multiplicity of 3, then it's going to cross through like this, right, or it could go the other way around, right? And if it's even multiplicity as we had in the do now, right, with 3 had a multiplicity of 2, right, 2 is an even number, then it will bounce off the x-axis, right, it will not cross through. And so, this is not a formal mathematical proof, but it does make intuitive sense, right? So if it's odd, right, it actually like behaves like an x to the third function, or an odd function. For this, right, if it's even multiplicity, it behaves like a parabola, right, x squared. So that's convenient for us to remember. Okay. All right, but yeah, make sure you have this diagram in your notes. All right. Is anyone still copying this diagram? Okay, if not, then I'll move on to the worksheet. So worksheet, let me actually jump to the second question. Okay, so on the worksheet was 2 questions. The first one was a graph. The second one was find the zeros of p of x equals x cubed minus 2x squared minus 4x plus 8. Okay, so for the homework, you're gonna, there's gonna be 4 graphs, but the first thing you're gonna do is factor. So there's some practice in that. You also want to indicate the multiplicities in this question. But yeah, for the factoring, it's going to be, so I factor out x squared from these first 2 terms. You get x squared times x minus 2. and then I factor negative 4 from these two terms. So you get negative 4 times x minus 2. So from there, the common factor is x minus 2, so you get x squared minus 4 times x minus 2. This is an example of factoring by grouping. And then from there, x squared minus 4 can be factored to be x minus 2 times x plus 2 times x minus 2, which can be written as x minus 2 squared times x plus 2. Okay, so the zeros, therefore, are 2 with a multiplicity of 2, and negative 2, which has a multiplicity of 1. Okay, and this actually allows us to draw this graph without making the intervals. Okay, so for your homework, you actually don't have to draw the intervals anymore. Like, you don't have to test the numbers, because with the information that we saw in that diagram, right, with the multiplicities, we know how the graph behaves at each x-intercept. So let me draw this really quickly. Y-intercept was negative 8, so I would draw that in really quickly. I know this is not in the question, but just as an example, right, negative 8 is a 0, sorry, the y-intercept, and then 2 and negative 2. 2 and negative 2. These are the zeros. So multiplicity of 1, I know the diagram said okay, one thing I have to point out is, one thing that the diagram did point out was m has to be greater than 1, but if it's equal to 1, then it'll cross through, like as you see in the do now, right? So the other two zeros had a multiplicity of 1, right? 1 had a multiplicity of 1, and negative 2 had a multiplicity of 1, and they both cross through. They might not behave like this, right? It might not look like a cubic function, but it does still cross through. Okay, so end behavior, it's going to be, negative on the left, so it'll be like this. It's going to cross through at negative 2, multiplicity 1, and then, let's see, then it crosses, so it has to hit the y-intercept, positive 8. My bad. It's positive 8. Yeah, positive 8. Alright, quick sketch. Positive 8. And then for 2, right, multiplicity of 2, it'll bounce off the graph. So it'll behave like that. Okay. Alright, so not the most detailed graph, but it gets the job done, right? We have the end behavior, we have the x-intercepts, negative 2 and 2. We know the multiplicity, so we know how it behaves. So negative 2 has a multiplicity of 1, so it crosses through. Add 2 has a multiplicity of 2, so it bounces off. And then the y-intercept is positive 8 here. Okay. All right, let me end here. Closing announcements. There's SGI today per usual, 2:47. Drop by if you have questions. And I said this earlier in this class, but the next quiz will be next Friday. So not this upcoming Friday, but the next Friday. That'll be quiz 7. Just FYI, I want to give you a heads up. But yeah, that's all I have to say. If you have no further questions and you're done copying this, you're free to go, and I'll see you all tomorrow. All right, take care.
Thank you.
Thank you. Bye.
All right, you're welcome. Bye.
Yeah, have a good day.
Thanks, you too.
Can I ask about the cost